Today, I'm going to be presenting you Introduction to Python Programming Language. Let's get started. On this video, I will present you the entire Python programming language syntax. Operating system is going to be Windows operating system. I'm going to be discussing functional programming as well as object-oriented programming, modules, libraries, and the Python ecosystem altogether. And I will also present you the actual presentation in a PDF file in my website, which is going to be also listed in the description of this this video. So please watch it and enjoy it and learn it. And if you have any question, make comments, subscribe to our channel and enjoy it. Okay, thank you. So let's get started with what I'm going to be covering on Python introduction. In this class, I'm going to have an agenda. So I'm going to have what is Python, the history of Python, philosophy of Python, Zen of Python. Variables, I'm going to be discussed and the data types, different data types, and then Python is also dynamic data types versus like Java or Go language that are static, and C and C++ that are just static data types and strongly typed data types. Python is dynamic. You can change variables as you declare them. And then you could just assign them new variables, new data types, and Python will not complain. Function programming is very, very kind of efficient. You have learned a lot of procedure language and function programming in the past, whether it's C, Pascal, Ada, Fortran, a lot of programming language, including C, C++, support function programming. Python also supports function programming. So you write a function to return a value and then you call it. However, with function programming, Python is both functional as well as object-oriented programming. All the four paradigms of object-oriented programming is supported by Python classes and inheritance, polymorphism, encapsulation, abstraction. All of those four paradigms are supported. And a lot of it is when Dunder methods, which is double underscore methods. These are also called magic methods, which are defined in Python libraries, and that every library comes with some magic method or double underscore method or Dunder. Under is double underscore methods, and I will show you a few of them when we do experiment with the string integers and list and all the tuples, data dictionaries, list comprehension. Each one of them are data structure that these functional programming as well as object-oriented programming works. And then I'm also going to talk about the decorator and generators and whether they're useful. And these are going to be discussed, but however, I'm not going to just talk too much about object-oriented or decorator and generator. I'll give you the ideas and explain it to you. Then on the subsequent video, I'll explain decorator and generator specifically to help you out further in details. So object-oriented programming, there are classes, and classes consist of objects and object. You instantiate it, you have properties and methods to an object which are part of that class. Then if you inherit something from the parent class, the child class has all the data that is already populated in the parent class. At the same time, all the methods and properties of the parent class are inherited on the child class. So object-oriented programming is very, very efficient. A lot of programming languages like C++, Java, Python also. Python does not have that method of called class or but it's object-based, and it does support through extract classes configuration. It does not actually have the keyword class, but it has extract, and you do the same thing. C also has extract and union, and then other ones that are defined to do it. But C++, Java, and Python, they do have classes, and then they just define these classes, and then you initialize some objects to be of type that class, and you just work on it. So I will tell you details of these ones because I mentioned these times wise, but I'm not going to be just exactly the same discussion as we go through them. Otherwise, it's going to be boring if I just talk about one thing and do not demonstrate it. So I'm going to just go over these lecture view, and then I'll show you in the lab view the same concept again. Control flow, comprehension, in condition and looping. So the control flow, we have if statement, a while statement, looping, and all branching, and basically whether it's a if statement or a while statement or a for statement. On all of them, there's a control flow that it is going through them. And then list also has list comprehension, and then you could just define list comprehension. You have also tuples, data dictionary sets as data structure that you could do with the control flows, that you could compare something and then do something with it. And then there's condition matching is basically some condition that you do. If this condition happened, do this. If that condition happened, do that. Else part, do that one. So all of those one conditional and branching is part of the programming. And loops are just whether you use if statement and then you call a for loop with it, or just a for loop by itself, or while loop by itself, and then it's looping to do multiple work at the same time. This looping versus the generator is different. Looping, when you do a for statement, you're creating a kind of sequence of either numbers or string or something to loop through them. The whole data is in sequence. It's allowed at once. It runs at once and generates from 1 to 10. It just runs all of them. But with generator, they're based on memory. So when you do for 1 to 10, kind of generate some numbers, the next item that is available is through iteration, it is going to be just available to you. And I'm going to show you those things. As you go through the next item, then you just do it. Yield is the actual keyword for the generator that you could do it. Yield. Control flow and comprehension, I just mentioned it. Modules and packages and the standard libraries. So Python comes with a lot of standard libraries, like, for example, math library is part of the standards. And then, for example, random is the part of the standard. And then a lot of them. So MATLAB, not MATLAB. Math is there. SES is there, OS is there. A lot of them that are defined as standard libraries, you can use them as regular ones because they're part of the built-in. And then the way you do it is if you type in dir and then onto the Python, it will just tell you all the standard libraries that are already exported or imported. So and what you do is also you can install Python that are not part of the standard. For example, NumPy, for example, Pandas, Request. Some of them that are not there, Matplotlib, any of those ones, you just do with pep install and then install it and then import it with Python once you're inside Python. And then the standard libraries are a lot of them. There's so much of them for different scientific, for AI, for data science, and so many of them. TensorFlow, and then Pandas and NumPy, all of them, regular expression. There's many of them. Popular libraries, the NumPy, some of them are very popular. This is for scientific. You can watch my videos. I have like 5 or 6 videos just on NumPy module and explain different methods and different functions that are with different examples. So you could do it. Pandas is very good for data sets and data frames and kind of big data. manipulation with kind of similar to our language. Pandas also supports Python. Pandas also support data frames and data sets. So you create a data set and you manipulate the data inside the data sets and data frames. And then you have a lot of SQL and MySQL and database on those database. NumPy supports MySQL kind of modules to install it. At the same time, Panda does for the data sets for that purpose. Request is for web, and then there's a lot of kind of URL kind of based modules. One of them is request modules, and I had discussed some of other ones, Beautiful Soup and other ones at the time when we discussed it. FastAPI, Fast Application Program Interface, another module very useful for doing API calls. Python modernized version is 3.10, 3.12, and then also currently the current version is 3.14. So if you go to python.org website, you will see the latest and greatest version that is available for both Windows and Linux is Python 3.12. Then I'm also having a question and answer wrap up, so you learn from it for your interview or classes or something that you understand that you finish this introduction courses on MyWebUniversity.com. What did you learn from it? You will be proud of what you have learned and how much it's going to help you in 1 hour or maybe longer. What is Python? First, let's discuss what is Python. It was created by Guido van Rossum in Netherlands in 1991, named after Monty Python. So interpreted language, it's an interpreted language and dynamically typed. It's not a static type. Dynamic meaning that you could define it and then at any time you could just reuse that variable with another data type. If you declare a name as equal some name for a string and then you just use name as equal 10, that doesn't make sense. You don't do it, but usually if you just define some variable x, you can just assign a string to it. You can assign an integer, a floating point, or a real number, or a complex number, magic numbers, anything. You could do that one with dynamic data type, and Python will not complain. In multi-paradigm, this is related to object-oriented style of programming language. It is both functional programming as well as object-oriented programming. Just in object-oriented program, there are 4 paradigms that I mentioned earlier: abstraction, or which is data hiding, and then abstraction, encapsulation, data polymorphism, and inheritance. Those 4 paradigms are all supported by Python programming language. It's a procedure or functional programming as well as object-oriented programming. So a procedure and functional is the same, like Pascal and Ada, Fortran, and then C. All of them are procedure. PL SQL, procedure language, SQL, SQL, standard query language, or also based on procedure or functional programming. And then emphasize readability. Python is very good for readability. The code is written in C. C is very clear, and then it's the mother of all these languages, actually. And then since it is used borrowed from C syntax and kind of a style, and then a lot of code like Python regular expression, Python NumPy, or written pure in C to make it faster. So that when they write it in C or C++, they want to just say the interpreter would act like as a compiler binary file. That's like machine code instruction that's native to assembly code and binaries. So at that time, you could just run them, and it's going to be very efficient. Like I just mentioned, NumPy, regular expression, RE, all of those ones are written in Curl, Lab, and MATLAB, and some other ones are also written in C. There's a lot of them that you could use them. Emphasize readability. Is very easy to read it. It's not like Perl script or some other languages like that you have to read the instruction 6 months from now, and you say, let me just parse it again and again to see what I meant on that one. Sometimes it's better to just do on some coding like Perl and write it as smaller lines rather than one line continuous and then pipe it to the next argument and next argument. That is going to be very hard to read. So even if you write it in Perl programming, write it in like variables and then just change the variables with another kind of piping. But C and C++ and Python and Go language are very clear in readability. They're all modernized. Code is read more than written. PEP 8. This is PEP 8, and that is Python enhancement packaging. I believe I forgot the last P. Largest ecosystem of libraries. This is Python is by far the largest ecosystem of set of libraries that people use the high computing environment, supercomputing environment, and then AI stuff, machine learning, and a lot of us, we are constantly using it in high performance computing, HPC environment, as well as TAC. I used it a lot with TensorFlow and other ones. And then we also used it on Gattaca too. We use a lot of Python and coding and practicing it and stuff like that. For artificial intelligence, I have used a lot of Python in both Claude and Gemini in the Google Workspace. So that is very, very good in the ecosystem that once you learn the knowledge, you just kind of use it and build website on the fly and create a lot of the automations and tools, whether it's on connecting to an Oracle database, MySQL database, or a data set, big data with some other one, or some kind of machine learning codes, or some kind of machine learning or data science that is doing all big data, Pandas and NumPys and this and that. Web interfaces, a lot of web programming and a lot of automations and scripting. So Python is useful for all of that. The whole ecosystem has a rich set of libraries that you can enjoy. The Zen of Python, important, this is about 18 or 20 Zens standards kind of understood, and that this has to be like a deployment kind of availability that that standard is already defined. For example, beautiful is better than ugly. So your code has to be more beautiful than just ugly coding, and then not write indentation and not writing smaller functions, and the whole code is a top-down program. Those kind of things are looking ugly. So Python, like C and Go and other ones, are very efficient, very robust, and then very beautiful to write. And explicit versus implicit. Python codes are explicitly defined. You, as a programmer, you tell the code what exactly you intend to do. That is what is important. Explicitly, you define things, and you define for a purpose. And then, even though if you declare a variable on Python and you don't use it, the Python interpreter is silent. It does not complain. In comparison, that if you do declare a variable in Go language and you do not use it, it will throw an error at compile time. Java programming, for example, throw an error or warning, not an error, but it will throw an error warning saying this variable was not used, but it was declared. Python is very silent. It just says, well, if you declare this variable at this time, maybe you might use it later. It's very forgiving. So it is your choice, but don't just create 5 variables and you just say, well, if Python is forgiven, I don't have to use them. Why do you create them in the first place? Simple, Python is very simple versus complex. Even though like C++ code are very efficient and run fast, but in order to understand C++ code versus Python, it is much easier for a student to learn Python faster and Go language faster, because when C was efficient, C++ was written for a purpose. Yet the complexity of it got added similarly to other languages. Sometimes other languages also add those complexities. Python and Go language are very simple in order to understand the concept and start coding. Readability counts. It's very important for another programmer to look at your code in Python and understand your code and not get frustrated. Error loudly. So Python, if it does fail something, it will give you a trace back, and then you could see that trace back, what caused the problem and how to fix it. And this was created in 1991, as you can see, by Guido van Rossum, very nice guy. He was in Netherlands, 1991, and he started coding. And then this is the Type B 2024, it was #1, but this one has been changing every month. Something changes, so it might be like 18 or 17 now or something. So don't just bet on this to be always the case when it was there, because all other languages fight for it. 500,000 plus libraries. That's a lot of libraries, and it's a lot. That's on 2024, but it's a lot more now. So the list of libraries are on PyPy. That is another website.org, and then you can just go. I'll show you how to get to these documentations. Very useful at MyWebUniversity. I have printed PDF files that I could show you. Inside my PDF file, you can find hundreds of thousands of technical documentation on the internet for all these programming languages, for all the Linux manual pages, for PowerShell, Windows, and Linux Red Hat, Linux Ubuntu, Rocky, all in one place. Just visit MyWebUniversity, and you don't need to buy books. You could learn it forever, and forever is free. And then all it is just subscribe to our channel. So everything that I post, you could get it right away from that website. So at this time, I want to pause a little bit, because I've been talking with at MyWebUniversity website, and I will show you a little bit of the technical documentation, why it makes sense for you to just subscribe to MyWebUniversity and watch these videos, and why don't you need to buy books. I show you exactly everything that you need is in one place. Just visit one place. You don't need to go to the library. You don't need to go to the bookstore. You just sit down on your home or at your convenient with your cell phone or with your desktop, laptop. The documentation is at your fingertips, and you can just find it. Let me just go to the website and show you first. I'm going to skip this one. I'm going to come back to this one. So let me go quickly through the videos, and I'm going to take you to the MyWebUniversity here. And then for MyWebUniversity, you can see that I have videos in English, which is about 2,100 videos online for these topics that are very college level courses or boot camps. You don't need to pay for boot camps or expensive courses at college. Just come and visit for free and learn it for free online. Everything, more than 2,100 online videos in the topics of operating system, programming languages, databases, and then all kind of DevOps and IT related courses for both students, developers, data science, artificial intelligence, coders. Anyone is welcome to learn from it. And just for the videos, you could learn it everything here at the same time. If you're interested to learn it in for C, Dari, there I have 517 videos in Dari language teaching computer science courses to everyone that speaks Farsi, whether it's from Afghanistan, my country, that I was born from Kabul, Afghanistan. I was at the high school when I left Afghanistan during the Russian war. And then I finished my college degree at Cal State Fullerton for both Bachelor of Science and Master of Science. And I have been doing 36 years of IT and software engineering, computer science consultation, database programming for prestige companies. And at the same time, as full-time, at the same time, I taught 8 years part-time and teaching at National University, Computer Learning Center, Cal State Fullerton, and Pasadena City College, compiler classes, C, operating system, C++, Oracle, MySQL, everything you can name it on that is covered under computer science major. I have touched or covered it or done work on it. So I'm here to help you out, and you will learn a lot from it. Let me just, first of all, show you the website where there's more into the website. This was the channel. The Direct Path to Linux Ubuntu is my online book. It's 15 chapters. I wrote the entire Linux manual pages in Python that generated both Red Hat Rocky Linux, for example, about 12,000 technical documentation. You can just find any of them. Each one of them you click on, it will tell you that PDF technical documentation. Usually you don't have this one on any kind of web, including Google and other ones. You have to go to redhat.com or python.org or let's say ubuntu.com or some website to just see the PDF. If you logged in to, for example, the Rocky version, you could get the same technical documentation for Rocky. So each one of them you click, you get that one and Rocky. And I give full credit to MyWebUniversity, Python, Rocky, and free PDF, the Python program that I wrote to generate this one from a text space and provide you on the browser. So this is all kind of like documentation. Similarly, like for example, for Linux release Rocky, I showed you the C++ header files, and then the Ubuntu PDF technical documentation, as well as dynamic generation of Linux Ubuntu. So for example, today I'm showing you Python. If you just go to this dynamic generation of PDF files and you click here, by default, I show you the ZSH, which is Z shell on PDF file. And you can see here the technical documentation comes in. The nice thing about this technical documentation, Python has both functional programming as well as object-oriented. So if you go to the Linux manual pages, right here you say cat -n etc os-release, you can see that I'm on Linux Ubuntu 26.04, the latest and greatest version. So here, if I say which ZSH, if ZSH is installed, you have the binary there. And if you want to see the manual pages, ZSH, you type in ZSH, and then right away you could get all the ZSH. So last time I created a website called linuxonbrowser.com. The reason I named it linuxonbrowser.com is for you to just come and learn Linux on browser. That one, I registered a domain name. It is redirecting to mywebuniversity.com automatically. And then you come in here, you say, okay, on the mywebuniversity.com, I want to learn ZSH, like I did here, the ZSH. Let me just go back on the this one. So this is chapter 15. You can actually practice commands here, pwd, and you will see it. So cat -n, I didn't have to go on the shell. I could do it on the browser, Linux OS-release. And then you could, sorry, I mistyped it. Cat -n etc os-release. Now I typed it correctly, and you will see that this was the command I typed, and here's the output. And this is running dynamic on MyWebUniversity. That's why I call it Linux on browser. So you can see the date is today's date. If I say show me calendar command, the current month of the May. So if you say, okay, Wahid, can you just prove that one that's dynamic? Let's just do this. We say cal minus b 5, meaning that show me whatever is the current month 5 months before that one, dash b. Now you can see and that May is here 5 months before that. If you say cal minus a 5 months after May, then you see May is first shown, and then 5 months after is October. And then it will show that one. If you say, give me the epoch calendar, cal 9070, that is January of 9070, you could see here is January 9070. So this is not tied to only running commands that I do. On those chapters that I did here on MyWebUniversity.com, let me show you. While I'm here, I want to show you something useful today. So for example, today I'm going to make this presentation, this PowerPoint presentation that I did already here. So once this one is done, I have already prepared for you this presentation to be on my website under presentation page and available for you. So you could just go and download the entire PDF file. How cool is that? Right? And then if you're interested to start coding, for example, you say, okay, can I just practice this one? Yes, you could. Just copy this line. Let me just show you quickly. And you just go here and then you highlight what is there. And from here, you highlight up to that line and then say copy. Then you open up a command prompt on either PowerShell on Windows or on Linux. It doesn't matter. Whichever one you do, you just do this. So let me just right away say make dir temp. I have the temp directory. Here I'm going to say code and then say hello.py. So I'm running Visual Studio Code to just cut and paste from the presentation to show you how you can just do the work here, right? So let's just do this, Control V or paste it right there. And now the code is pasted here. You can see that it created on the fly there. So now I'm gonna, since I installed under the module Vim, which is a VI improved, I already have installed the extension. Now I can learn the syntax of, I can run the syntax of Vim. Right here, you see colon WQ. When I press escape, I'm typing WQ to write and quit. And then now I can close this one. And then now I have this file, hello.py. So if I just want to test that one, obviously, dir hello.py, it is this. So if I say Python and then hello.py, and then I just run that one. And notice I'm going to say type hello.py. This is the code, which says, hello Python, welcome to Python 3.12. Guido created this one. And then Python is this, simple this. So that was the output, because right here I have the print statement and hello, and then Python is going to be printed, and then name is assigned to a string Guido. Year is 1991 as an integer number. Version is 3.12 is a float. Is awesome, is true as a Boolean value. So then you call those variables that we declared, you just say print, and this is the f string. F string meaning that whatever I write within this string, I could put that, for example, the version string within the braces. Now it's going to pass on. This is similar to printf statement on a C, C++, and Java, and print line on Go, and so on. You could pass on arguments to it. Printf name is right here, define Guido, and then it's going to say Guido created Python, and here this. So now you can see that one. If I just run it say Python hello again, and then you can see the above lines that are right here produce the output that is this, because of this variable declarations. So if you say, that is cool, can I see that one in code? Yes. So you type in code hello.py, and you just open it. And now here in code, this program is very nice with the IntelliSense, and sense it has nice colors and everything and format. So at this time, if I just want to say run and debug, I can click in here and then debug it, run and debug it, because Python is installed already. And I could run it there and trust workspace continue. Now it's going to run it, and it's going to give me an output on the terminal. So right here, you also have a run statement. You can run the code here. And now it's here, variables are defined, watch, and then call stack. So it's much nicer IDE, integrated development environment. You could just look at it there. When this one completes right here, and then show automatic Python configuration if you want to see, or you could click here. Clicking here, let me just move this one to the right and move my zoom out of the way. So you can see here is the code. I can see the whole code, line 1 through 19, by moving out, up and down. Once you see the code, you say, okay, what is the output? The output is right here at the button. And when you run it, it just says that, okay, Python -u, and then the name of the Python it was running here. And then here's the output. At the same time, you have a terminal here. And terminal, so if you go by default, I'm not on the temp directory. So if I do a pwd, my current working directory is on virtual environment pwd. So if I just say get dash location, that also provide pwd kind of things, because alias pwd points to the get dash location commandlet. So if I say change directory to C:/temp, now I do a clear screen and do a dir, you can see hello.py is there. And then if I say cat, let me see that alias cd is also for set location. So whether you type set location, C:/temp or change directory, it will do the same thing. CD is the alias for it. So now if I say alias cat is for get contents, and alias type is for get content, and get dash command, get dash content, get dash content. This is all PowerShell. So you can see that you're very powerful with PowerShell. At the same time, with Python, you're very powerful as well. And Go language, and C, and everything. So everything you learn is useful. So if I say cat hello .py, here it is going to print it and there. And then you can also, with this one, if you wanted a little bit more colorful, like if you just move up this one and do this one, this is going to show all in white, the color. But if you do this one with out dash rainbow, that is going to show you a little bit more colorful. And also there's a utility called laugh out loud cat that comes both on Mac and Windows. You have to install it, and it will give you that sequence of colors. So if I just say, go ahead, run Python and hello, hello.py, I can see that code online here. So if I just say, go ahead, clear screen. Now, if I just do clear screen, semicolon, and say cat minus cat hello.py, and then also semicolon Python, and then hello.py. This is one line code. It clears my screen first, then it concatenate the file, and then it runs it to see the output. So let's see that one in one shot right there. So the clear screen already cleared it, and then this is the cat command, and then the output is written below that one right here. So how useful is that one? The next thing is that when you're inside Python, if you just want to practice something else on this one, obviously, the more you go on this video, you will just see more options. So like here it says Python 3, 2 plus 2, and then hello dot upper. So if you just don't want to cut and paste this one, you could also go on your Visual Studio Code and just size this one to just go next to the other one. You can see here on the one example, and then right here is where you have Python example. So in here, I'm inside the code, right? So if I just go inside here and go to Python, now I'm on the Python interpreter. If I say, go ahead, do 2 plus 3, that's going to be 5. 2 plus 2 is going to be 4. So print statement, and inside print statement, you could say 2 plus 2, then it's going to just say this one. 2 times all the modules and other ones, like 10 mod 2 is going to return 0, but mod 3 is going to return 1, and mod 3. Mod 3 is going to return 1, and so on. And then if you just want like a math of modules, by default, I told you that some of the modules are already available here. So at this time, I'm going to minimize this screen, and that way you just can see this one bigger, and I'll show you some Python with default. So every time you get into the Python, if you just type in here, say Python dash version, it will tell you that I have Python 3.12 version. And if I want to know my operating system detail, right away you could say system info, and then just say OS name. And then this one is going to run the system info binary, find the string, pipe it to find the string, and search for the OS as for OS as well as name to a string. Wherever it finds the OS and then name, it's going to return those ones. But if you just want only to search for find the string with one character, that is going to return you one line. And you can see that it's actually this one is not returning OS name like that. So you have to do escape /i, /i, meaning that ignore the case, because the OS name was written OS in uppercase and name was uppercase, so the -i ignores it, and it will pick it up for you. So you know that it is on Windows 11, and now I'm using Python dash version 3.12. Now, if I go to the Python 3.12, what am I doing? What am I doing is here, I go to Python here, and then do a dir, and you can see I need to clear my screen. So I could do a print statement here and say double quote / new line times 20, let's say, and then see if that screen moved up 10 lines. But this is still the top line is there. So in order for me to completely clear it, I could do the same thing with 50. And then, but notice I'm stand up on the bottom. I want to move up on the right. So in this case, I say import OS module, and then dir of OS now it has a lot of functions, right? One of the function is system. Another one is popen. So with those ones, you can actually do those methods to just call the system. So if I say os.system, and then I say run the clear command, since I'm inside the DOS at this time, I type in CLS. If I type in clear screen, it might not recognize it. It says, I don't understand, because it goes to the operating system and it detects it's a DOS command. In order for me to use PowerShell, I could just do this and it will still work. So notice that was the difference. So if I just do a PWD here, print working directory, it's not going to recognize. But if I say PowerShell, then PWD, it will work. So just a note for the developers, if you're looking on coding like this with Python, some of these ones are very intuitive, but at the same time are hidden. So if I just say right here, clear screen, it would work. Now on this one, what if I just want to know something with OS system? So I could say system info and then find /i OS name. Notice this one is going to work because I have to put this double quote with single quote here, and then on the first one also with single quote. One of them has to be single quote, the other one has to be double quote, and then it would work. So now you notice that it's there. All you have to do is, like, if you want to get another one, say like memory information, you could just do that one. But at the same time, if you're looking for not OS with mem, and just type in memory to escape the memory, that would give you memory information. But at the same time, if you just say, what if I want to know my Python version? So notice Python version, you can say Python -- version, that would work. However, in Python, there's a module called sys module. So currently, I have not installed OS module. I mean, sys is automatically here. OS is there. NumPy is not there. Some of the modules are there. These are the double underscore methods that I was telling you that is there. For every module, you could look at the doc module, the name of the module, the packages that are there, the specification, and there's so many like contains or this and that is equal or all of the other ones based on the module itself. So if I say dir of sys module, then you can see sys module has a lot of methods and a lot of double underscore methods like that, and then a lot of other exception like variables and attributes that you could set. For example, if I just say os.system and then clear the screen here, and then come back here, say sys.version info. This would give me the Python version information. Major is 3, minor is 12, and then micro is this. So that would be equivalent to that Python -- version. You can see 3.12.0, 3.12, and 0. That's how it is there. And if you say sys.version itself, it's going to just tell you that it's 3.12.0. And if you say sys.platform, that says that it's on Windows in 32-bit. If you run this one on a Linux, it will return POSIX, which is a Linux type of operating system. And then if you just say sys.executable, you get the path to where Python executable is. So every time you type in Python, it will go to this directory to run that one. And then if I say sys.path, you can see the entire path here. But if I exit out of this one or quit out of this with left parenthesis, right parenthesis, I'm here. Now notice I'm on my virtual environment and on the TIM directory. If I just say, okay, I'm inside PowerShell and I want to just get this environment variable. The way you do is you say echo $env : path. That will just give you the path of this, the entire path there. And command and DOS, you go echo $path. I mean percentage path. Percentage. That would give you that. But notice that I'm inside DOS. So if I say version, it tells me the version and volume and directory, and then all the information is DOS related C:. My prompt change from that. But if I exit out of this one, now I'm back on PowerShell. And if I type in a path, clear screen, path, it's going to just say, I don't understand it. If I say a percentage path, and that, because it's not defined in PowerShell like that. In PowerShell, you have to say $env, and then the string path, and that will just return it. So this is different environment versus the Windows environment. That's how it works. So, and another one, environment variables and user profile. User profile, it tells you what your profile is. So if I'm going to the DOS prompt, you could say echo dollars percentage user profile. That is going to return the same thing as dollars environment and then path. This is just for your information. When you're using Python, whether on PowerShell or Linux or anything, I will make another video for introduction to Python on Linux also, because a lot of people, they get confused, like, okay, why do I have to know both languages when I'm only programming on Windows? So if you're interested to learn it on Windows, this is the video for you. And if you're interested for Linux, I'll make one for you as well. But let's go back to my presentation. So today, when I make this one, that documentation I told you I'm having already here. And some other videos that I already made it, you could just go here, for example, go Node.js, a course that I just made a video. You could just also get it. And this is also put on MyWebUniversity Dari channel, as well as the other ones. For example, this one is SQL 24 on MyWebUniversity English channel on the video itself, but at the same time, it is all available under presentation page here. And these meta tag is for Google to find it for the search engine. Usually when you do these kind of courses, people are not gonna know it unless the word of mouth, and some people are nice enough that they share it with their friends and loved ones, and they say, oh, I've learned a lot from this one, let me just introduce it to you. But at some point, I made this one, made a tags, did a dictionary kind of information that Google search engine, when the SEO, search engine optimization, index all of these ones, they will just find it easy for you. So when you go to google.com, for example, google.com, and you say, I want to look for a PS3 command in PDF format. So you type in this string, say, give me the PS3 manual pages and Linux in PDF format. So you just type in on Google, and the first search that comes in is from AI saying that the PS3 command is what? It tells you that, then it's gonna give you the URLs that find it. The first URL that is on the top list is MyWebUniversity. You can see how valuable my tools are, my resources are there, and they are coming up from companies that have done a lot of, they might have millions of kind of videos and not videos and documentations and a lot of developers, everything is moving forward for everybody. But at some point that one that goes on the top list, that is the quality and quantity and kind of availability and accessibility, and everybody appreciate free stuff, right? So if you go here and say, okay, give me the PDF documentation, that's my PDF at MyWebUniversity that I wrote on Python, and I gave full credit to MyWebUniversity, my website, because I'm hosting it. I pay for the internet, I pay for the website, I pay for everything, storage, hardware, and then services that I provide, and then I code it, and I spend a lot of my valuable weekends and all of these in vacation times to just produce this kind of knowledge base to help generation to come. And this is all for future generation, and future generation are going to be much better than us, and they're going to just help and shine and help their family. And God bless you if you are doing the same cause that I'm doing and helping others to inspire other people in the future. 20 years, 10 years, 100 years, nobody is here. So if you look at it, we produce something for our grandchildren and for communities to come in the future, and they all could benefit it. So this kind of technical documentation is useful. If you type in PWDX and PDF, let's see what it shows up. So notice that some of the documentation, other website has it, right? PWDX on PDF. That's PDF is matching their PDF series. There are different things, but some of them, at some point, you're going to see MyWebUniversity and manual pages and there. If you're just interested on only at MyWebUniversity to do it, you could just say MyWebUniversity next to it, or site mywebuniversity.com. And this one will just show everything that are matching on that. So like, for example, you're looking for NumPy, you say NumPy, Python NumPy. And if you don't put MyWebUniversity by default, every videos, if you look on the video section, right now I'm on the all section. You can see here, there's people having videos and alls and this and that. But if you look at the videos section, you can see that there's Python courses on YouTube, videos and this and that, right? And then if you're just saying that, show me what at MyWebUniversity channel has, MyWebUniversity, now your search is more kind of towards one specific site. So you say Python NumPy, at this one now you see that one is coming at this. The first one is NumPy, the ones modules or functions, the info and so on. This is all at NumPy at MyWebUniversity, you can see here. This is another one, Python NumPy tutorial number 2, Python NumPy module OS 2, and NumPy matplotlib tutorial number 8. You can see use import NumPy as load NumPy modules. These are all at MyWebUniversity. So I have made all of these ones, and unfortunately my subscription are really low compared to the 2,100 videos that are very structured, kind of organized and with technical documentation, and that supports it on website, as well as all the technical documentation is college level or higher, or sometimes at least close to college level. So because I taught at the college, I know what students are looking for, and it's going to help you. Just go there and then enjoy learning. And so coming back to this lecture, we're going to go through the lecture now. And let me just pause for a second. I need a little bit of water, and I'll pause it for a second. Okay, last time I was on this slide discussing this hello.py, which I showed you on Visual Studio Code, as well as PowerShell terminal, that I ran the code and I got this output, as well as I explained some of these ones a little bit more with variables, declaration, and so on. So I'm going to show you on the right side what I have, and then we will continue on these examples from the lecture. I'm not going to jump back into the terminal and practice it. I showed you how to go to mywebuniversity.com/presentation page, and then all these presentations are there. I'll post this PDF presentation page on my YouTube video description, so you can find it as well there. And if you forgot where how to find it in the description, just go under mywebuniversity.com/presentation. All my presentation that I'm posting moving forward, I have at least 6 of them for now, but I will add more of them, and then you will see it. For all videos, I don't have the presentation. Some of them could have been on the Google Docs that I posted before, or just discussed it and put it on the description. Excuse me. So I'm going to get more on the side. Okay, so at this time, we're going to go through the right side. It says print. Print is a function. You're using a left parenthesis, right parenthesis. The older version 2.7 did not have this syntax. The left parenthesis, right parenthesis was not required. You could do that one, but now print has a lot of other functions. One of the functions is f string. Another one is draw string. So you could pass on arguments as raw characters or as f string to pass arguments to it. You could do that one. But it's a built-in function, no import needed, automatically is available for you. And there's any type of automatic. The type is a mamash, you don't have to say %s or %f or %d or something like C and C++ and Java or Go. You just print it using print statement and automatically does the type. The reason is type is dynamic, not casting it or static. Not static. The comments are with pound sign and like shell bash scripting. You do this one common. A lot of languages supports bash style of comments. Perl does it. Python does it. And then with the C and C++ and Java is double slashes or asterisk slash asterisk and then asterisk slash to close it for multiple string. And then with Python is double three string is for multi-line comments. This is also called the doc documentation. Multi-line, either three double quote, closed by three double quote, or three single quote, closed by three single quote. Within that one, as many lines as you want, as whatever format you do, and the interpreter will ignore this altogether. It will not read it. The same thing, the interpreter will ignore the comments. It will not do anything with it. The f string is stored with f, either single quote or closing single quote or double quote, closing double quote. And between them, you put the format that you want. On the older version of Python, there was a format a method or a function. You could do it, but a newer version is much cleaner. You just use f, and then within the braces, you put your variables like this of f and then name or year or some version. All of that one is there and that very neatly. F is called f string, and so a function string, fast and most readable string formatting, and it just replaces the old 2.7 format command. Any expression inside the braces, you could do it. The expression, you could say 2 + 2 or something computation, an expression you could put inside, or you could just put a variable there. It will just read it and do it. This one I already explained, the triple quotes string for multi-line content description. This is for documentation purpose. You can either use 3 single quote or 3 double quote, but make sure when you start with 3 single quote, you close it with 3 single quote, not with 3 double quote, and vice versa. No semicolons. So Python, like Go language, does not require semicolon. Like JavaScript does not require semicolon. But sometimes you could put it, and it's going to be ignored on JavaScript. So since it's not required, you don't need to put it. C and C++ and Java and Pascal, you have to use semicolon to end a line, say line terminator. Even with Bash scripting, it's not required, but if you do multiple lines in one interactive shell session, you have to separate them either with an or a semicolon, depending on your logical statement that you want to run. No semicolons is needed, new line ends statements. Indentation is by 4 characters. So whenever you use a F statement or something, you indent it by 4 statement. Like here, this is just for writing it in a very nice format. That's why multi-line string was written in that way. The same data will be outputted the way you want it. So a F statement, a for statement, and other ones that when you do it, you have to get that block with the indentation. Usually it's 4 spaces. Define code blocks mandatory. That is required. It's not like option. Python, hello.python. This is just saying that the output was done when you run the hello.py. The Python interpreter was called. In Linux and Windows, you can also say, for example, on Linux, you could say shebang, use a benenv, and then the Python interpreter as an argument, and then you could just run the hello.py as a separate executable. Run it as an interpreter. I also made a video last time discussed with PyInstaller modules. Read that video. I discussed PyInstaller with virtualenv, as well as installing virtualenv. I installed PyInstaller module, built in some Python program that compiled it with PyInstaller. When you create it with PyInstaller, you could create standalone executable like C and Java. So if you're on a Linux, and if you do a type on that one, it will tell you as an executable link format type of file. It's very neat. So Python variables are dynamic and they're not strongly typed like Go or C or C++ or Java. Python are dynamic. You can create them and you can reassign them to new variables. Like here, no type declaration, Python infers. So when you declare x is equal 42, it knows and infers that this is a 42 is an integer. Again, y is 3.4, it infers that it's a floating point number. Name is a string. By double quote, it says it's a string. That's how it infers. But like Go language, it does not infer. You have to type it, strongly type, say x is equal and x and then 42, or bar x string type name and then whatever the string value is. Flag is this is also supported for true and false Boolean variables, Boolean algebra Boolean, and nothing is none. This one is like null. So none type and like null values or none, and so you can assign something to be not null or none. Type int Python 3.5 enough. Operation but great. Optional but great. So when you write this age colon int is equal to 25, moving forward from 3.5 up, you can have this syntax also to say age integer and is equal 25. Is score colon floating, and then the data type you can say it specifically, but it's optional. And then greeting is string and hello. So numbers, you can also use the underscore, so it's much easier to read. Readability with underscore is much easier. The Python support you to do this one. If you have like 9-digit zeros, sometimes it's very hard to read. But if you separate them by underscore with 3 spaces of zeros, then it's much easier to say this is 1,000,006 zeros. So big number, and then binary 0, B1010, that's a 10. So if you define a binary, since 0B and then 1010, you can see that is a 10. If it was just 10, it would be 2. If it was 111, obviously 111 would be 7, and 1 would be 3. So that's how you calculate those ones. Then you can also have hexadecimal value, like 0xFF is 255. And then complex numbers is a 3-digit, 2 numbers is a real number plus a magic numbers, imaginary number we call it, and has a J in front of it. This is called complex number. And so dynamic typing variables type determined at runtime. The variables, when you run it, you know that, oh, this is an integer, this is a float. It's at runtime. It's not at the time declaration. And Go and C and C++, they're at compile time. If you declare something to just be integer, the compiler has to know that it's an integer. It's strongly typed. The same variable can hold different types. That's why it's dynamic in Python. None, Python and null, only none and false and falsy, 0, empty list, or also falsy, unlike Ruby programming language. Type hints, when you create a function or a type, you say def as the keyword, and then in this case is greeting, is name, colon a string, and the return type is optional. So you could say IDE and tools, but not enforce at runtime. These are not enforced at runtime. Immutable types. Immutable types, usually when you think of immutable type, you think of tuples, because data are read-only, a snapshot kind of things. So you create a tuple that is immutable. You cannot modify it, you just cannot change it. But all integer numbers are always immutable. You cannot say 5 and then assign 5 to something else, or floating point 5.0, or a string Wahid. You can not change the string Wahid. Obviously, if it was a variable called name is equal Wahid, you can change it to Lutfi or whatever. Tuple is, these are immutable. Int, float, string, tuples are all immutable. But list and list comprehension and dictionary sets are mutable. That means you can say a list sub I and then assign a new value, or dictionary key pair value of it, you could set a different value, or set, you can assign a superset of a set to a set, and you can just change it. Important for correctness, so make sure you understand that. Everything is object. So a number is even an object. An integer is an object, a name is an object, a string is an object. Since they are always an object, they usually point to a kind of class. For example, if you say name is equal Python, now a name is a type of, when you do a type on them, it says class string. So class string, meaning that you could say name dot upper, it will just change upper method, it will change everything to uppercase. Name dot lower method, and then it will change everything to lower method. So that is also, everything is object. For example, 42 dot bit length, when you do a dir of floating point number or string or any name or something, you see all the methods that are associated. One of the methods for the integer 42 object is bit underscore length. It tells you how many bytes or bits of character is for the storage size. This is same as Ruby, unlike Java and primitive type. And Java has its own primitive type, not everything is an object. You just have to define them as type of classes. So this one is a string immutable sequences. Like here, S is hello Python. And then when you say S dot upper method, right away, everything changes to upper. This S is when you do dir of S, one of the method is uppercase, lowercase, title, so on. So all of that one is doing it. So S split, when you split it by space, by default, when you do it by comma here, it writes instead back to a list. And the list now has two elements. One of them is hello. S sub 1 is the list, whatever you assign it to a variable called L1. L1 sub 0 is hello, and L1 sub 1 is going to be Python. Bang. And then here, right here, so you say S0 to 5, it writes from H all the way to 5. And that is going to print hello, slicing. This is called 0 as starting and 5 is maximum, 5 not counting. So the first four characters. 1 sub 0, sub 2, sub 3, sub 4, sub 5. And then that will just print out that. And then this one is -1 is to reverse it, and the same thing. But notice the two columns. So whatever was the entire 0 to 5 string or 0 to 10 string, that one you just read it, leave those two blanks and -1, it just return the same character in reverse order. Length of S is going to give you how long is the string here. From 0 to 14, all the way, there's 14 characters. Collection and mutables. So my list, you define these ones a list to define. Now notice define a list. You could define integer, string, floating points, and booleans, all in one list. Orders mutable, ordered mutable. So this is an order. This is sub 0, sub 1, sub 2, sub 3. If you're printing my list sub 3, it will return true. My list sub 0 will return 1. And then my tuple is 1, 2, 3. It creates a tuple separated by commas, ordered, immutable. These are all ordered, but they're immutable. They're not kind of changeable. My set list, notice the tuple is left parentheses, right parentheses. List is like similar to dictionary braces, but the syntax is very important. If you write it that syntax, then you have to know this is a set. However, this syntax with braces is a dictionary. It's a key value pair, key and then value, key value. So every time you create a dictionary, it is just a list of dictionaries that are even on a dictionary. The reason it's called dictionary. On a dictionary, when you open, there's a word and then there's a value for it, what that word means. So a dictionary is a key and then a value, a key and then a value. So if your name is the key, the value of it would be Wahid. If your age, the value of it would be your age. Type conversion. How you do the type conversion, this is called casting. This one is also supported in C and C++ by casting it. So 42 was a string, and then by casting it into int, it just converted to an integer. A string 3.14. 3.14 was a float. We cast it to a string, and then that's why double quote you see here. List 1, 2, 3. This is a tuple, and you convert it to a list. This is a class a list by itself. By doing this one, you cast it to a list type, and now it becomes from a tuple 1, 2, 3 to a list with the bracket and right bracket 1, 2, 3. Boolean 0 is going to be false. When you do it, Boolean 1 would be true. So bool is the method that you call it to convert. And so none is we explain immutable type with everything we covered here. So now function first class a decorator and generator. In order to understand this one, we have to define what is a function. So a function is something that you write it once and it returns a value and you use it many times. You don't have to define it, you just define it once and then you recall it as many times as you want, and it is always available for you to do different values and different argument being passed on it. So greeting is the name of the function. Name is one argument. These are called position argument. That is name, and then greeting is equal hello to parameter position parameters. And this is a default value. Greeting is hello. This is a default value. So you can see return F a greeting name. And then if nobody passed it, they just call the greeting, then it's going to say hello name or name hello. That is how it's going to be printed. Print greeting Alice, in this case, is hello Alice. So hello is always passed as a greeting, and then the name is, in this case, is Alice. Say greet Bob, hi. This one says hi Bob. This one, it replaced the greeting default value of hello to hi. That's why the value is hi Bob. So if you didn't want to do that one, you could just say greeting name, and then it will say automatically hello, like Alice right here. And then if you wanted to say a different string, you just have to pass on the second argument to whatever string you want to say. Args and key args. Keyword args and args are very important. This is basically, it's written on C, C++, Java. whenever we pass on from command line, we're reading a bunch of arguments from the command lines. And there are different type of arguments. One is the first one, which has an asterisk, args. This is a positional argument. Positional argument is different than keyword arguments. The keyword arguments is like a pointers, a string, double asterisk, keyword arguments. This one is a key value pair. It's like a dictionary, keyword arguments. So the keyword that you pass in, each one of them has a value of it, like a data dictionary. So you just pass in there. Dictionaries has a method of items and keys. You can use it also. And also when you do this one, start key or W args, you can see, for example, within a for statement, if you say for A and args print A, this one is whatever is the position argument is done, that's going to be printed. But in the case of key args, you have a key and a value. So you say for key and comma value and key word args dot items. This dot items is a method that has a list of keys and values. So you print the key is equal to value. And this is the if string that uses the braces, and you can do that one right away. Log, when you write a log here, message, message to, level, info, user, ads. So this one is basically, it might be a little bit cut off here on the left side. Let me just see there. Usually this one is similar to like a message that you're writing. If there's no function define log, then you might have a def or something in front of it. But this is one string and another string, this level, and assign it there. So Lambda anonymous functions. So in Python, you could also use anonymous function, which is also called Lambda function. And AWS and Amazon Web Services, a lot of Lambda functions are being used on the cloud computing or basically AWS kind of structure. A square, for example, here, lambda x colon x to the power of 2. This is going to do x to the power of 2. As soon as you don't have a name for it, and then you say x, and then colon, and then the expression that returns the value of x to the power of 2. So then if you just pass on numbers as a list, 1, 2, 3, and then you just say the squares, and then list map square nums, and then this map is another function that it takes every square to return a different numbers, and then at the same time you could put it into a list, filter it by lambda function. This is x module 2. Whatever is this module 2, if it is positive numbers, return the nums. This is like remainder is 0, meaning that it does a 4 and 16, and then the other ones are remainder is not 0. So 4 and 16 is remainder 0. Decorators wrap functions. So decorator, it does not modify the function, it enhances the function and wraps it in order to just generate the values for you, and then it will just enhance it basically for you for better purpose. So when you say def timer, timer is the function, in this case as a decorator, and then import time, you import the time, and def wrapper. Wrapper is the one that you are doing here with args and kwargs. Start time, time method, result function, and then args and kwargs print took time this much. It shows you how much elapsed time is happening from the time and then floating points, and return result, return, and then this is how you call a decorator with add symbol. So the timer that you define here, you just use it here. Default arguments, we talked about it. Args, we talked about. Decorator syntax, sugars for a function. Decorator function used for logging, auth, caching, and timing. And generator yield pauses execution and return a value, resume on next item, and then memory efficient for large sequence. This is for big data. It's a very memory efficient generator, and then every time you need the next item, you use yield and it will just generate it for you. So first class functions or objects, assign variables, pass an argument, return from a function, is stored in a list. For some reason, I'm getting very tired. I don't know why. Let me pause for a second. I need to get some water. So in this example, we're showing the slow function, import time, and sleep time 0. This. Slow function took 0.0 this. Then we use the generator lazy sequence memory efficient. So we use the def Fibonacci function a comma b 0, 1, while true, which is always true. When you say while true, yield a. So every time pauses and return a value. And then a comma b and b comma a plus b, and then that would be the return of Fibonacci numbers. And Fibonacci is recursively called here. Then you say print next Fibonacci for n and range. This for underscore, meaning that you don't define a variable, you just discard the name of the variable and you just do the yield on each one of them. And then range of 8 numbers. So for each of those numbers, it goes through the sequence of that range and it prints out the Fibonacci numbers, the next numbers. Generator expresses like a list pair, but lazy. Bakes squares x to the power of 2 for x in range of 1 million. That is a big number. The x to the power of 2, that 1 million to the power of 2 is huge. So it is what it is. We have to just take it. And using generator is going to help you. Object-oriented Python. So Python has object-based classes that you could have methods and attributes and you use them. Here, a class animal is defined, species count is starts 0, and there by default, this is the instantiation, and net double underscore init. And in this case, an animal has self as this kind of type of method in JavaScript and Java, and then also has a name and has an age. This is the constructor in C and C++ in Java and other languages that are called. Self.name is name, and so name is assigned to self.name and age is assigned to self.age. And then animal.species count and becomes 1, increment 1 once you just assign this one. The first one gets instantiated, the animal species count automatically get the incremented. Notice that animal is the class, and then the variable is, species count is right here as a class variable, declared as a class variable. And then the methods speak, self, and then it says return a function f-string self.name makes a sound. So whatever is the name of the object, in this case, it will just makes the sound. If it's a cat, it does meow. It's a dog, it barks, and so on. Class method add, this is like a decorator add class method. So you say def count class, and this is a class of type the class information, class method, not a member method, right? It's a class method. So return class dot species count returns it, and the static method is also a decorator, and then you say as a valid age if it ages 0 or less than 100, then it's a valid. If it's return either 0 if it ages not born or greater than 100. Otherwise, return the age. So double underscore init, double underscore string, double underscore equal, double underscore length, or all the special method or called magic method in Python, and magic method and Dunder method also. Add class method, here you see add class method, receives the class CLS, not instance. So this is not based on the object, this is based on the class. Instance is the object itself. Receive the class, not instance. Used for alternative constructor or class level operation. A static method, no self or CLS. Notice that it does not have the here like count here. It does not have the self or class. Just a function in the class namespace, use it for utility functions. Data classes, the data classes auto-generated and double underscore init represent and then equal like Java record code structures. Okay, so I'm going to go to the next one, and then here object-oriented string is defined here, the double underscore string, like to a string. It converts the string to a string, and then animal self.name and returns self.age in a string method. This is representative. Dev reps animal name is representative, which are somewhere here, or earlier we saw it right here. And then equal self others, you check for equality if they are equal. And this is the double underscore operator, or double underscore equal as double underscore similar to double equal sign. Inheritance, for example, class dog, if you just create this one, animal, dog, cat, everything could be an animal, right? They are instance of the parent class, so dog inherits everything from animal class. So you define a dog to be inheriting animal, and between left parenthesis, right parenthesis in Python, you do the name of the parent class. In Java or C++, you say use the word extend. So you could extend the class to the parents. Def double underscore init, double underscore self, name, age, breed are just variables that are initializing it. So dog has a name and age and how he breathes. Super init, name, and then calls. So this one is super class that instantiate name and age. And self.breathe is breathe, and then speak. The dog would bark, and then woof woof, or cat meows, and fish doesn't talk, and so on. And then you might just say fish, I don't know how to talk. Multiple inheritance, unlike Java, class service dogs, dog trainable pass. So you could also say pass and then define it later on, but as multiple inheritance. So not just one level of parent child class. You could have sub classes that are inheriting from the subchild or something. Data class Python 3.7 and up, auto double underscore init, representative ego for data on this one. Data class point X, and these one I'm not going to read each line by line. You could just do that one and practice it. And it does not make sense to just say the variable, this is assign this value when you already know it. You could just practice it. It's much better. Cut and paste it and run the code. If else if a statement, when you do that one, if the score is greater than 90, grade is 8. This is Python if statement. If otherwise, else part is going to execute else if or else colon. Notice the indentation is colon and then indented 4 characters, and then do that one, and then the else if under the F, else is there, and then if all fails, it goes to the else part in this case, and it just does that. Ternary condition, you could also do ternary condition, assign grade pass if score is greater than 60, else right fail. So it does check condition and assign in this one. This is compare like if statement that is all 3 lines or something. You could just write it in 1 line here. Indentation is 4 spaces. We already talked mandatory, not an optional, consistent, and this one. For a statement in Python for an always iterator over sequence, no C style of this. So the C style or Java style or JavaScript style, they all support this I is equal 0, I less than n, the length of that one, or I plus plus, or I minus minus, whatever you do from increment, decrement. That information is on C and C++, Java and Go and other ones, but JavaScript, but not in Python. Enumerate function is there, Go index and value together, no manual counter needed. Match 3.10. Structure pattern matching, and the structure matches complex data structure. So pattern matching is, or regular expression, is also available in Python. There's a module called RE, regular expression. It does that. Comprehension, one line, less dictionary, set of construction, faster than loops, more readable. So you could do less comprehension, you could do less and doing it rather than just looping it through it. NumPy actually has a lot of those kind of vectorization and then vector and matrix kind of multiplication with arrays and NumPy arrays, and that one is very, very good in terms of arithmetic and kind of computation that you cannot do it in list. List is slower because it is not written in C. NumPy is written in C, and it does support it homogeneous kind of arrays rather than heterogeneous. List supports heterogeneous, and that's why it is slower. So walrus kind of syntax. This is symbol is in Pascal. Colon equal is like an assignment statement in Pascal, and then in Python it is optional. In Go language is also available to assign and use it. So on walrus is the kind of animal that has a teeth like this sticking out, and so that's why the symbol is called like walrus symbol. If you look at the walrus picture on some website on there, you could see it. Let me show you that one actually. I'm on 5 and I just see here, and we just say go to google.com and say walrus. You could see walrus images, and then just to get the actual teeth, you can see that symbol right away. You can see it's right there like that. That's why that symbol is called walrus. Okay, so we're back on 5. I'm going to just start from where we left off here on 5, and walrus was there, expression, assign and return value in one step, while chunk this one is you see it assigns an expression, but at the same time you can have also a chunk assigned to that one and then also do some computation in one line. So like for example, chunk colon equal f.read, this file that is there, you read 8 kilobytes of data and then process it as a chunk that is there. So you define it first. Once you read it, then you process it. That's how walrus is helpful in one line. Here match statement, Python match condition also has case statement similar to if statement, but doing case. So case quit, you quit. Case help, provide the help, or question mark, show the help menu. Case go, direction, do move direction. Case anything else, no. This is not a no. For loop plus range, for I and range of this one, print I. The for loop has like for item and range. This range has a start and an end and an increment or decrement value. So you could just use the range function in Python to do that one. It's very useful. And then you could do print I. For I in value and enumerate, so this is enumeration data type is of A, B, C, 0, 1, 2, or getting the value of enumeration and value, and then you print and then the value. In this case, I is index is 0, 1, 2, and then value is A, B, C. That's how this one is going to be printed. For KB and my dictionary items, print key value. Dictionary.items items or keys or two methods that return all the items and key pair values. So you say K for key, K for key, and the V for values, and you just get them in values there. Very easy. So we discussed that, and then now we're here. The while condition also in Python is iteration or looping, and then we are having this one already discussed. On the left side, while condition, while this condition is true, do some work, and if done, break out of the loop, and then if escape, continue. That's these are statements are also important, break and continue, to see whether you want to break out of the loop or continue with the loop. So list comprehension Python superpower. The list is very good because the comprehension makes a list much more powerful. Like x to the power of 2 for x in a range of 10. This one says whatever is the value of x 0 through 10. So the first one, 1 is still going to return 0, is going to still return 0, 1 is going to still return 1, 2 become 4, and 3 become 9, and then 4 becomes 16, and 5 becomes 25, and so on. And then square of it. So this one, even number, if this one, the F modules is going to check the remainder. If the remainder is 0, then for numbers between 0 to 20, it's going to return only the value of even numbers. So it's going to print 0, 2, 4, 6, 8, and so on. And that's there. If you wanted not equal 0, that would return numbers like 1, 3, 5, and 7, so on. Matrix ij times, this is doing matrix multiplication I to the power of j, and now notice the for statement has two different variables, j and I. So I and j are multiplied to do matrix multiplication. The size of this range has to be the same, otherwise your matrix multiplication will fail. It will not work. If you define this one 3 elements and this one 4 elements, obviously that's not right. And then NumPy automatically has a lot of methods on this one to do this kind of vectorization. On R programming language, watch my videos on R and C++ on vectorization. I made some videos. I explained those ones differently. They are much more efficient than less comprehension. Less comprehension is slower, but it is working. However, you want to do it with NumPy when you're using Python, and vectorization, vector on C++, and R is a vector also element to just manipulate it there. Words, w.upper, this is just kind of changing it to uppercase. For W and text, dot split is split it. Dictionary and comprehension is also, you could do the same thing with list, you could do also with the dictionary. So square root of x to the power of 2 for x and range of 5. And then here, unique sequence x to the power of x. These are all kind of list within the list, and at the same time used as a dictionary outside of it. So once you have this list and to manipulate, then you define them as a data dictionary. And generator expression lazy, and so total sum x to the power of 2 by x range of this. Generator is very nice because it yields one item from memory at a time, and it's much more memory efficient and faster. Module package and what is it? Module popularity libraries. The name of the how many modules are there that come as a standalone, how what you install. I'm listing here some of them, but these are not just everything. There's more than 500,000 or more modules there. OS is for operating system, sys for system packages, pathlib for path, and then import a path to do path. You can say import OS or import OS as some X or some S or something, import sys as S or something, or you could say from pathlib import only the path, or from OS import only system. You just say import from OS import system, or from OS import popen. All of those ones you can do that. And then from the module name import some method name, or comma more method name. You can say from date time import date time and time delta. From collection, import counter and default dictionary. From typing, import list dictionary option. So from package utilities, import this one. From package, import models. And then you can also install Python modules with pep. Pep3 and pep are very good, efficient. You can do pep dash version to see if your version of pep is matching your Python. There, what version you have for pep, what version you have for Python. And then some other modules that you can install, like NumPy for scientific math operation, foundation of scientific Python, Pandas data frames for data analysis, like Excel and Python, big data, essential for data science. Matplotlib for plotting and visualization. This one I also use for R language for a lot of graphics that I showed you visualization. Heat map. FastAPI, modern async web API framework with automatic OpenAI docs. And SQL Academy is for database, ORM for database like Hibernate for Java, and Active Record for Ruby. So pep, you can use those ones to install these modules, request, pandas. You can put all of them in one line and then you can just install them. It's better to just do one at a time to make sure that you are getting successful if you're not watching it. Request HTTP mod simple import request. And this one we're importing the request modules. So notice with the S at the end. And so the response command request.get method, and you put the URL that you want to get. And then now response.json will just return your JSON data for that one. And response.url will just return you this URL. Your response.text will return you the text portion. Response.byte will return the response the bytes in binary. Response.header will give you the header. So many other information. Do a dir on response and you'll see all the methods that are available. Pathlib, modern for path, ppath and data, and this one now p.read text and p.write text need content. So the data is read and then the data is back written. Words, and this one is a collection, is a dictionary. Apple, banana, apple define. Word sub 0 is apple, word sub banana is 2. This one, rather than call it words, it should be fruits. It makes sense. Count, counter words, and then counter apple 2. This one is just doing the count on the number of words with calling that method counter. Data class plus typing. Data class, import data class field from typing, import class var, and then add a data class, which is a decorator class config, and then you can configure the port and IP address and the host name and string and tag it, all of that. And then these are comments, a virtual environment, Python -m, a virtual environment. So if you just do create a virtual environment, you say Python -m means module, virtual environment. The name of the virtual environment is virtual env. Source virtual env ben activate. This is on Linux, and then on Windows, you PowerShell, you say Windows activate this one, and then .ps1 is for PowerShell, and batch BAT is for Windows. You could run them. Pep install -r requirements. This is once you freeze the requirement on your virtual environment, you do a pep install from this requirement.txt. It will just read from requirement.txt and install it, your updates there. So a quick reference reminds us that Python has a string manipulation and less data structure, string data structure, dictionaries, tuples, and then sets, and then integers, a lot of different data types. You can also do file IO, exceptions, and then async. So for the string, you can see you define a string hello world, then you can change it to a lowercase, you stripe it or replace it, and some character of it, and join it to something, and then start with. All these methods are coming with a string class. Similarly, with list, you define the list here with this syntax, and then a.append will add 9 to the list of this. A.pop will remove the last item from the list. A.source sorted, and A.reverse and sorted in reverse. And A:1:3, meaning that show me from this 1 to 3, this is 0, item 0, 1, 2, 3, and then 4. So the 3 and 1, 4, 1 will be printed. And then similarly, A:2 will just do everything from back 2 items outside back. So summary of A minimum. No, actually, this one is saying that all of them, and then the second item is up to the last 2, and there. Let me just double check that one. I believe that. Okay. So I'm gonna just quickly go to Python here. The way you check something, you say Python, you say A is equal a list of 1, 2, 3, 4, 5, and then you say A sub colon 2 will return you return you 1, 3, 5. So this one is 1, 3, 5. So move this syntax says move to the 2 digit in between. So 1, 3, 5. If I have the list A as 6, and then 7, and then 8, and then 9, and then 10. And this one, and now I do the same thing, A2. Notice it skips one of them, 1, 3, 5, 7, 9. And then the 2 is not there, that's even numbers, right? So if I just change this one to 3, and then it skips 3 numbers, 1, and then it prints 4, and then 7, and then 10. That's how that syntax means. I hope that explained to you clearly now. Let me just go back to the slide that we were here. I think we were here, yeah. Yeah, we were right here. So how many more slides is that? Not that many. So we're on slide 20, and 23 slides are left. 23 altogether. So I'm gonna say slideshow from the current, and then we talk about this one, and then X4, X, and sum, and minimum, and max. These are kind of methods that are available by default in Python, but then there's a NumPy and other ones. They also provided math library provided, so you have to be careful if you're using average or sum or maybe count or anything. Make sure that you're on the right modules. if you see any discrepancy. Dictionary is as a key pair value, so key is A and value is 1, B is value is 2, key is B. And then d.get, it will get the character C and return that one to you. And then d.keys will just give you all the keys, only A and B. The d.values will give you the values 1 and 2. And then d.items will give you key pair values. So each one of them. This one is assigning a new margin with whatever you have A colon 1 and B colon 2, you merge this one, say A colon 1 is 1 key, B colon 2 is second key, third key is C colon 3. So this will be appended to the end of your dictionary as that one. This is saying that the D is a pointer, double pointer, keyword args, and then you assign this key value pair. Remember that I showed you the keyword args and say they are based on key value. And depop, when you do the depop, the last item will be popped from the A dictionary. A is popped in this case, none. If it is found and there, it will pop it. But you can also do pop to just remove the last item. File I/O is very efficient in Python. You basically use the width. It automatically does content management cleaning, so you don't have to say close and if descriptor, file descriptor, the open. Python take care of it in the content management. So at this time, you just have, say, with open file f.text as f, file descriptor f. When your the scope of this what statement is done, this f automatically close. That's what is efficient about file I/O. So you do assign a f.read to a text, and then every line you can put it into lines with f-read lines. And then when you write it, you just declare. You can reuse the same file descriptor, but I would also kind of to not get you confused if you're doing anything like this, because this file I/O automatically close it. If you're doing it in a C or programming like C++ or Java, you don't want to do this one with the same file descriptor name, because the content manager in Python cleaned it for you, but you might not remember that you open a database connectivity with the file descriptor, you read some record on the table, now you want to write to it, and then you're just having conflict there. So with open output as f.write hello. In short, you can use the variable in Python the same for read and write, but not in other languages. Don't do that. Exception, try, risky. So this is try exception, and then I'll finally what you have to do it and raise a return value. Go language does not have these kind of syntax. Java has it, Python has it, and all of the languages they support try except kind of methods. But if the language is designed to be efficient, like Go, you don't need to write all of these case statement, try statement. You could still do that one. Pascal doesn't have some of those ones either. But it's still, they are efficient. Go language is very efficient. Async, import async IO. Async IO is just supporting you to do async input output, and then async def fetch URL, async with session. So this is very efficient for context switching. So it does task with async IO. Task in a process, you could just have threads, and each threads could have task A, task B. So between task A and task B, it will do some kind of switching, task management. So in the case of async, usually it is much faster, more efficient than just regular programming, and that it's not async IO. And then for a for statement that does 3 different numbers, you could do it with async, and it's going to just be more efficient in terms of how many times you sleep. And between them, whenever it does context switching, it does it to the highest number of sleep there. If you have sleep 1, sleep 2, sleep 3, only does sleep 3 rather than 6 times each task. Having 1, 2, and 3, that's total of 6. But if you do async, it's only 3 for the biggest number. Async run, and they all run concurrently. Async IO run main, and then await. Await is the process that, I mean, the reason that you're just getting it faster. It switches the task and then awaits, and then it wakes up, and then it just finish it when they are done. Async for sync with that. So in this case, I'm going to give you a summary between Python versus Java versus Go language versus Ruby. Because if you're a developer or Python programmer or C programmer or Java or Go language, you want to see what is efficient, what is best to use what. And they're all best. They're all efficient. You can enjoy all of them. Just to give you a thought. So for example, on the features for data type typing, Python is dynamic. And like I mentioned, it's dynamically created. It's duck typing. But Java is static. Explicitly, you have to define it. And also, Go language is static, but it is inferred. And so Java is more restricted. Go language is inferred, and then static. And then Ruby is dynamic and duck typing, similar to Python. That's the beauty of it. Object-oriented programming, Python support multi-paradigm, abstraction, polymorphism, encapsulation, inheritance. And then Java is class-based, restricted. And then Go language abstract and interface is used, not classes. And then Ruby is pure object-oriented. Everything is object. And Python is also everything object, but Python supports both object and function programming. Null or just in Python is none or falsy, and Java is null or not PE risk, and then Go null pointer only, and then Ruby is null objects. Error handling, try and accept in Python is there. In Java is try, catch, and throw. And Go is val, error, return. And then Ruby, begin and rescue. Concurrency, async IO, we just showed you that one in Python, and gel limit. And then also on Java, concurrency is handled by threads and BT 21 version. And then for Go, it's Go routines and built-ins. Go routines handle the 2 channels also. Ruby, threads and reactor. Compilation, obviously, compilation, it is an interpreted language. C Python is also C language kind of syntax, compile Python. There's also PyInstaller that you can run to create a standalone Python programming, but they're not executable by default. It is an interpreted language. Java is Java virtual machine, bytecode kind of syntax that you get the bytecode, which is close to the machine code, but it's not native binary code like Go or C, C++. Go is a native code and is making it executable. You can run it with Go run and name of hello.go, or you can say Go build hello.go, and it will build the executable .exec on Python, elif on .exec on Windows, and elif on Linux. Interpreted language is Ruby is interpreted language like Python. And then the speed of it, Python is C, unless you use the C extension libraries like NumPy or regular expression or other ones. But Java is fast, just-in-time compiler, it has it. And then Go language has near native because it has kind of memory management as well as close to binary executable, very close to native. Not like C or C++, but it is very fast. And then also the most efficient in compilation, Go language. Slow, Ruby is very slow, unlike Python, and may not have any C extension library on Ruby. Package management, you do it through pep or poetry. So Python has pep, but you could do pep install or poetry or conda for anaconda. And then on Java, you have Maven or Gradle. Maven is very good on Java, so for package management, you could use Maven. And then also for Python, Go language, you have Go module, and then you could declare it, and you can do all kind of module. Like the other video I showed you how to do a Go install devboots.dev or something. And gem in bundlers for Ruby. Primary use is for Python is artificial intelligence, machine learning language, and data science and web programming, and a lot of general purpose programming, game programming, and this and that. But Java is primarily for enterprise, Android, and web programming and network programming. Go language is very efficient for cloud microservices, Dockers, command line, and API calls, and general purpose games and other stuff also. Any programming that are supported to run and compiled and executable files get created, they're faster and they're more efficient for games also. Games, you want to do it in assembly language or something else, or C or C++, and it's much efficient. Ruby, web Rails, and scripting for web stuff and also scripting. Learning curve, Python is also good for web scripting, and there's a lot of request modules and URL-lib and a lot of other ones that I have used, like HTML, and then there's beautiful soup, and then Pandas is also good for data science and other ones. So learning curve, very slow, very low. You could learn it very easily, Python. And then Java is high. The learning curve, it takes time to learn Java because of all these long names and long kind of buzzwords that they are using within the code itself. And then unfortunately, a lot of jargon kind of naming at the time of object-oriented that was done, and it was taking much more students and developers to learn the code, and then at the same time memorize the syntax, while an API calls or something in Python or Ruby could just do that much simpler, or Go language. Go language is medium, and then Ruby is low also, Python is very low. And so what is next? On this one now, you have learned a lot of it. Let me tell you go to Google and look for NumPy modules on MyWebUniversity. I have at least 6 videos, and very good videos to explain you all those ones. I might have had Pandas and Matplotlib as well, but RLab and Lab and data science, I have covered a lot of these stuff with the data visualization, data science kind of a stack. And then FastAPI, Django, Flask, web development, MySQL, structured Python language. I have a lot of videos similar, and you can look at them. PyTest, modern testing for framework, how you test in Python. Async, wait, concurrency, deep dive, and then Scikit, Learn, TensorFlow, PyTorch, and these are modules for machine learning and AI kind of large language models. Cython and C extensions, speeding up the Python, and FastAPI, talked about it. Package your own library and publish on PyP. So the resources, you can go to docs.python.org under that one, and exercise, and this one, real time and real Python, best tutorials, Kaggle, and then data science, and also MyWebUniversity. I did not list it here, but let me show you how you get it on MyWebUniversity. So if you go to mywebuniversity.com, and click on the direct path to Linux Ubuntu, and go to chapter 12, which is the dynamic generation, you could just get everything in one place. Like here, you just type in Python, and I generate you the Python technical documentation on the fly. You just get that one, and it's about 7 pages. You might say, how is that going to help me? Look, and the internet resources, you can do Control F, search for the documentation that is all HTTPS, or you just click on the python.org, docs.python.org, or pyp.org. If you go click on it, and now you're there. So you can search for modules here, list of modules. For example, if you search first NumPy, and it is there with all the details. Similarly, if you just say, okay, this one, I want to go to python.org, now you're on python.org. If you want to download, you could go click here. If you want to just go to documentation, click here. And then under documentation for 3.x resources, you have tutorials, you have libraries, references, and everything. So if you go to under tutorials, you can practice the entire Python programming language is starting from here. And let's say you want to create a list. For list, you just do this one, and then this values are there. But at the same time, you could just practice it on the command line itself. So if I just exit out of this one, and then I say go to Python, and then I say dir show me this, and now I don't have, if I say, let me say import OS, and then os.system, then I say run the pep list to see if I have a list of packages that are already there, and then notice that the list is huge, right? The list is huge, but then I want to say, is NumPy is there or not? So if I just say, do that one, and then do find a string here, I could do it from the command line itself by just opening another terminal and say pep list, and then that would just, I don't have to do it inside Python. And then I could do clear screen and say pep list and say find a string /I, and then say NumPy. That way I could see if NumPy is installed. NumPy is already installed. If it was not installed, I would have to say pep install NumPy. This would just say, and now it's already installed, requirement is already met. And then a requirement already satisfied, but also it tells me that if you want to just get more packages, it's a time for you to upgrade your pep. Notice that I told you the pep version might be different from the Python version. So how you check it, you just say pep -- version. Like here, that one is installed. Now, if I just say pep list as the list of the packages, and then say pep -- version, it is that version. Python -- version, it is that version. Pep list, and then find a string /I pep itself, then you can see the version that is there is 26.12, and right here is 26.12. Similarly for NumPy, and the version is there. Then if I just say, okay, get that one, let's just go to Python, and then it's a import NumPy as np. Now np is already installed. Now say dir np, it is all of these methods, so many of them are there. Notice the double underscore ones with the docs and dir and this and that, all of them are there. You can also get the help on them, say os.system, let me say, clear this screen here, and then you say, I didn't import it first. Let me import it, and import OS, and then clear it after. So now you say help on NumPy. That module, you can see this NumPy module, and you can practice it by just cut and paste something here, and then I start creating some array, some data structure and manipulation there. At the same time, if you say type of NumPy, it tells you it's a module. But if I say create an A for an array of 1, 2, 3, let's say that those 3 elements, type of A is a list. Now, if I say name is equal Wahid, and then I say a type of name, you can see, sorry, type of name, you can see it's a string. So name is Wahid, name dot, and then upper, that will change it to uppercase. Name and dot lower, it will change it to lowercase. Name dot title, it will just make one character of it, the first character uppercase. So you could say dir of name, you can see that it's there. This is the same as dir of a string, because name is a string data type. The same methods are available there. And then if you just say, like, look at the double underscore contains. So if I say name is equal Wahidullah Lutfi. Remember, I told you that type of name, now I reassigned the value. Because Python is dynamic type, if it's not static, I could reassign with different values. So now if I say name, it's going to say that name dot upper is going to change everything to upper. Name and dot double underscore contains double underscore, and that's the string contain Wahid. You could say if it contains that one, it's going to say true. But if I say Wahid 1, it's not true, because the name itself, it says that one. If I change it to say Lutfi, contains Lutfi, yes, it does. So you could do anything you want to do with them there. So name is this, and say name dot split, as the method split is going to split it into a dictionary. Now, if I just say name, is still a string. But if I want to assign that split into a list, say L1 is equal that, and then say type of L1, now that's a list. And L1 will be returning that list. L1 sub 0 is going to return Wahidullah. L1 sub 1 is going to return 2. And then L1 colon, this one will give me both. If I just say -1, this one, it will just say Wahidullah only, skipping the other one. And then at the same time, if I say L1 sub 2 is equal MyWebUniversity. So now I want to just assign L1 sub 2. So notice L1 has 2 elements. I did not have a sub 2 on it. And I want to add it. I have to say Dunder of L1, and then I have to look for a method that adds it. Here there's an add method. You can add it or append it there or extend it. You could do extend method or just add method, whichever one you do, or append method. So append method is going to say L1 is equal L1, and then I'm going to say double underscore add underscore this L1, and then put my web university. So this not added because name add is not defined. Let's see. Oh yeah, I have to say L1 dot add, because that object L1 has it, and so can only concatenate. Let's see if this one was added on the list, not assigned it. Okay, I'm gonna do, instead of add, I'm gonna do append. L1 dot append that, and then L1 now has nothing. So let's do this one. L1 is equal, L1 is this, L1 is equal, I'm gonna just define first the array. Sorry about that. I'm gonna just do Wahid and then Lutfi. So this is my list, L1 only. And then now say L1 dot append, and then say my web university. So if you forgot the syntax, yeah, you could do that one. Now it is added to this one. L1 sub 3 is going to actually 0, 1, 2. Sub 2 is going to return my web university. And then if you just say now do a for statement with this one, you say for I in range of 3, do the print, and then you say L1 sub I, and that would just give you those ones there. If you want the actual I, you could say do this one, and then with your I for statement on the print statement. What is the print statement? It just went up right there. You could just say I comma, and then that would say 0 Wahid, and then the element in each one of them. And if you create a dictionary, similarly, let me just do also a dictionary quickly for you. So I'm going to say dictionary is equal, I'm going to say name, colon, and then the name is Wahid, okay, and then comma, and then make one more this title, and then I'm going to just call it instructor, and then comma, and then sport, favorite sport, I'm going to say soccer, and then define one more number. So I'm going to say let's say age. I'm not going to give you my age, but I'm going to put a number here. Doesn't matter. Age, and then I'm going to just say 100. I wish I could live that long. I'll never live it that long. Never know. I could be dead tomorrow. Never know. So date is that, right? So now if I say dictionary.keys, and then that give me all the keys. Dictionary.values give me all the values. Dictionary.items, it's going to give me key pair values. So then I say for K comma V and D.items, and then say, and this separator say print K comma value, and then that's how we do it. Name is Wahid, title is instructor, this. And if you want to just give some kind of separator, obviously, put the double quote here like this. So for this one, and then the print here, and say, you can use the F string here, and then within the F string, you say brace K colon, and then put a colon here, and then brace this, and then double quote for the F string, and you're done. Let's see why it didn't do it. F string, I did not put a quote here. So let's just do this one, and then the F string. You have to start with F double quote here to say this one, and then now you're done. Okay. I'm gonna end this video. I hope you enjoyed. I hope you like it. If you haven't joined our channel, please subscribe to our channel. It's gonna help me make better videos for you. At the same time, I could pay off for 1% of my services that I'm presenting. Actually, it's a lot of cost, and their YouTube channels are never going to help you pennies per day. That's not going to help. I don't have too many videos to be watched. I mean, I have a lot of videos, not too many subscribers to be watched. So you guys are on your own. If you want to join, it will support my channel. I really appreciate it. Take care. God bless you. Have a nice one. Bye-bye.